We're at question 3 of our exercise on finding directional derivative. In this case, we want to find directional derivative of negative 8xy minus 4x cubed plus 16y to the fourth at 1, 2. Unit, the vector square root of 3 over 3i minus square root of 3 over 3j. Alright? So, there we go. Now, of course, as usual, we are going to find the gradient vector, but remember now, the directional derivative in the direction of the vector of the function is equal to Nabla f, which is the gradient vector, dot the unit vector. Now, the gradient vector is going to be delta, or the function by delta f, the partial derivative of the function with respect to xi, plus the partial derivative of the function with respect to xj. In this case, what's the partial derivative of the function with respect to x? So this part is going to be negative 8y. You see that? Minus this part going to be 3 times 14x. So 3 by 14 is what? 3 times 30, 3 fourths 12. 30 plus 12 is going to be 42. Right? Same as saying 4 3 is 12. 2 carry 1. 3 1 3 and 1 4. Right? X to the 3 minus 1, which is 2. This part is just 0 because we're treating y as if it's a constant. So it's that I plus delta f by delta x now, j. So it's going to be, delta f by delta y. Why did I write x here? Supposed to be y. My mistake there. Supposed to be y. Right, yj. So that's going to be negative 8x for that part. This part is 0. It's a constant. And with y now, plus is going to be 16 times 4. Give us 64. 64 y to the power of 3 j. Okay? You see that? Alright. I'm going to substitute the numbers x equal 1, y equal 2 in it from now. Instead of writing all of this big monstrous expression here. Again, right? A lot of things to write here, quite big and monstrous. So I'm going to reduce it. X equal 1, y equal 2. So negative 8 times 2 minus 42 times 1 squared I plus, and then x equal 1, so it's 8, negative 8 times 1 plus 64 times 2 cubed to reduce that monstrosity that we have. Alright, so that's going to be a2's, that's negative 16 minus 42 times 1 squared is 42. So you get, if you say 16 plus 42, going to be 58. So it's negative 58 I. Let me me just write that down, minus 58i plus, what's going to happen in this bracket now? You going to have negative 8 plus 64 by 8. But 64 times 8 is what? 512. So this part is 512. Negative 8 plus that, same as 512 minus 8 is 504. So this amounts to 504. J. Alright, nice. That's what we have. Let me put the J nearer. Alright. So that's Nabla F. Let me write it here again. Now what's the unit vector? First of all, let me just copy it and put it down here instead of writing it again. Oh no, I forgot I had copied this as an image. It's not like I can just copy it like that. I didn't write it here. So U is square root of 3 over 3. So the vector U is square root of 3 over 3i minus, I'm going to write plus negative square root of 3 over 3j plus negative square root of 3 over 3j. Alright. Now, the magnitude of U is equal to the square root of square root of 3 over 3 squared plus negative square root of 3 over 3 squared. So that is equal to what now? Square root of 3 squared is 3 over 3 squared is 9 plus square root of 3 squared again is 3 over 3 squared is 9. So, okay, that's coming on quite neat. This will be the square root of 3 plus 3 over 9. So it is 6 over 9. Let me just cut this part off and continue here. Which is the square root of 3 into 6 goes 2, 3 into 9, 3. The square root of 2/3. Alright, it's just the square root of 2/3. It comes down to. Alright, so now the dot products. But we're not ready for the dot product yet. Just work this out. Finish working it out and deal with it. Right? But I could still write it though, you know, as negative 58i plus 504j, negative 58i plus 504j dot. Alright, it's going to be another complicated expression here, another monstrosity inside this bracket. U equals, now the unit vector here, that unit vector going to be square root of 3 over 3i square root of 3 over 3i, but this part will be over square root of 2 over 3. Let me put the I some distance away, give it a little space, plus something j. What something will that be? J. In exam, you don't have to be keeping all of these fractions and square roots, you know. You could just work it out as a decimal from early, right? But I want to see where this will go. Should be a neat fraction when I finish. Square root of 3. Negative square root of 3 over 3. Negative square root of 3 over 3. Divided by square root of 2/3 j. Alright. That's nice. So, you know that this could be written as this part is the square root of 3 squared. Right? So, this is square root of 3 over the square root of 3 squared. Square root of 3 squared is 3. Divided by square root of 2/3. So you could have one big square root here of 3 over 9 over 2/3. So you could say the square root of 3 over 9 divided by 2 over 3. And this would be 3 over 2. So it's square root of 3 over 2, right? But anyway, let's just work it out straightforward now. You give 58i plus 504j dot. Let's just work it out as decimals. Alright, so what we have here now, square root of 3 divided by 3 equal that. Alright, that's divided by, let me put a bracket just to be safe, square root of 2 over 3 close bracket. So it's that over the square root of, oh no, I don't think I did, open bracket here and close bracket. The bracket should be here. The square root of open bracket. So this other bracket wasn't necessary. And this other one. So we have the top part over the square root of 2/3 equal 0.707. So 0.707i plus, it would be interesting to see what the other part is going to turn out to be. As you remember, 0.707 is the same as it 1 over the square root of 2. Right, it's really 1 over square root of 2. But let's see this part. There's a negative there, we have to remember. But the square root of 3 divided by 3 is that. Alright? You could use open bracket, close bracket, and that is divided by the square root of open bracket 2/3 close bracket. Now remember, there's a negative. Could put the negative here. Let's not bother to put it. The square root of 3 over 3 over square root of 2/3 equal 0.707, but there's a negative. Alright, it's really minus 0.707 again. So turn this into minus 0.707j. So what you have then is negative 5 0.707, as I say, is equal to 1 over the square root of 2. Right? So I could put this over square root of 2 minus 504 over square root of 2, right? It should be what? It's going to be negative 509 over the square root of 2, right? If you work it out as decimal, it would be about 360. Negative 360. About that. Alright? So, that's what we have there for the directional derivative.